Hi, we're going to go over Math 106 Geometry for Elementary Teachers, final review, 20 math questions. Let's get started. Number 1. Convert the angle to degrees, minutes, and seconds, and round your result to the nearest hundredths of a degree. We're given 92.58 degrees, and we need to write it down in degrees, minutes, and seconds, separate units. This is how we start. To find the minutes, we will take the portion of a degree, which is 0.58, and multiply that by 60, because that's like 0.58 degree, which is a portion of a 60, not 100. In money, we talk about 58 cents, but this is if it's 0.50, that's 50% of a degree, which is 30 minutes. So in this case, we multiply 0.58 times 60, and the answer is 34.8 minutes. We continue with the seconds, and we take the portion 0.8 of a minute and convert it to a second, multiply it by 60 again, and we get 48 even. So the answer is, in degrees and minutes and seconds. Degrees, it's clearly the 92 degrees. We do have 92 degrees point something. And the minutes is 34 point something, but we're going to take the 34 only. And the seconds will be 48. To double check, you could check doing the following. 92 plus 34 divided by 60 plus 48 divided by 60 times 60, which is 3600. Double check on this on the calculator and you'll take you back to 92.58. So this method is to show you how to go back from degrees, minutes, seconds. If you have 92 degrees, 34 minutes, 48 seconds, how to write it in degrees only, which is 92.58 degrees. And just to confirm, if you type 92 plus 34 over 60 plus 48 over 3600, the calculator will give you 92.58. Number 2, find the measures of the interior angles of the following triangle. Well, we are given that this angle and this angle are equal, and we know that the sum of the angles in degrees of any given triangle adds up to 180 degrees. So that's 2x, x plus 34 equals 180. Let's not write the degrees just for the convenience. Subtract 34 from both sides, and we get 2x equals 146. Divide both sides by 2. The 2 cancels, and we get x by itself, and x equals 146 divided by 2, which is 73. So that's a 73 degrees, and that is the same 73 degrees. Number 3, find the distance x, which is the hypotenuse, in the following figure. We know that a square plus b square equals c square. A square plus b square equals c square. Doesn't matter which is a and which is b, but for sure this is c. So let's take a as 3 square, and b will be 4 square Let's undo that. 4 square equals, c is being called in the problem as x squared. So we have 9 plus 16 equals x to the second. 9 plus 16 is 25. Apply the square to both sides. We don't need to write plus minus because it's a length. So we end up with x equal 5. So x equals 5, and that should do it. Number 4. Give an answer between 0 and 360, a clockwise rotation of 90 degrees. That means we are given this as 90 degree clockwise. Equivalent to counterclockwise. Counterclockwise of what? That is going to be this much right here, which is 270 degrees. Okay. Number 5. Find a pair of congruent triangles. State the congruency property that satisfies your conclusion and express the congruence with the symbol equivalent or congruent. Now notice we have the following. We have this side is marked like this side. We have this angle has the same mark like this angle, and this side they both share the two triangles, the one on top and the one on the bottom side. So with colors we could say that this side is equivalent to this side, and we have this angle, let's mark it with 2 marks, tick marks, is equivalent to this angle. We have this side they both share. So with that in mind, we could write that triangle ADC, that's ADC going in that order, is congruent to the triangle ABC. This triangle ABC. And notice that we have to be consistent and write the letters in the correct order. AD corresponds to AB. AD corresponds to AB, and so on. And the reason why, state the congruency property by side, angle, side. The reason why we are using side, angle, side, side, angle, side, side, angle, side. That should do it for number 5. Number 6. Suppose the triangle PQR is congruent to the triangle ABC, and we are given ABC. Where the triangle ABC is shown below, find PQ. Notice the following, that PQ is right here, the first 2 letters in that order. That should correspond to AB in the figure that is not, or the ABC is drawn, but PQR is not given. So, to find PQ, we look at AB, and AB is 4. So if this right here is 4 as AB, side line segment AB or side AB, that should be PQ 4. So find PQ, the measure of the side PQ is also 4. That should do it. Number 7. A pair of similar triangles is shown. Find the measure of the segment marked with the letter A. The letter A is right here. That's what we want to find. To do it, we need to write the proportion. We could do that with a scale factor and so on, but proportion will do. So the way to do it is we need to be consistent and write it correctly. For example, if I go A to 8, I should go 15 to 12, the same way. So let's do that. A over 8, A to 8, is the same ratio as 15 to 12. Then we cross multiply and we get A equals, or A times 12 equals 8 times 15. Divide both sides by 12 to leave A alone, and we get the following. The left side, 12 cancels, so we get A by itself. Right side is 8 multiplied by 15 divided by 12. We could reduce our numbers by doing the following. We could divide 12 by 3 and we get 4. We could divide 15 by 3 and we get 5. We still could simplify more, and let's divide 4 by 4, which is 1, divide 8 by 4, which is 2, and the only thing left is 2 times 5 on top, 1 at the bottom side, and that should give me 10. So the letter A is 10. That should do it. Number 8. In a school survey, students showed these preferences for instructional materials. About how many students would you expect to prefer films? Let's stay focused. Films is right here, and that's films. In a school of 700 total students. How many students? That means we need to go 20% of 700. 20% means 20 over 100. Of means times, and we have 700. Let's do this as over 1, so we could simplify. Divide by 101, divide by 100. Seven. So we have 7 times 20, and the answer is 140 students. Next, number 9. Find the mean, median, and mode. Round to the nearest tenth when necessary. For the mean, we just add them up and divide by how many. So we have the sum divided by how many? We have 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. N is 8, the number of in the data. So we divide by 8. And when you add 19 plus 3 plus 5 plus 8 all the way to 19, I have 93. 93 divided by 8, which is 11.625. But since we need to round to the nearest tenth, we need to make it only 11.6. That's called tenth. After 6 is called hundreds, and so on. So that should do it for the mean. For the median, we need to write the numbers in order. So the numbers in order will be 3 is the first one, 5, 3, 5, 8, then after 8 we have 15, then 19 3 times. 19, 19, 19, 19, 19, 19. Okay, I see another 5 right here, so I'm gonna go back and add the 5 next to the other 5. Here we go. So we have 3, 5, 5. Eraser. Okay, let's do this. Go backwards. 5 and 5 and 3. Let's double check. We said n is 8, so here we go. 1, 2, 3, 4, 5, 6, 7, 8. So we're good. Now, the way to find the median is the middle number after you list them in order. As you could see, we have 8 numbers, so we could do it by practically cross one from left. Let's do it with our marker. One from left, one from right, left, right, left, right, and we have 2 in the middle. Since we have an even number, n equals 8, we're going to end up 2 in the middle. Then we take their average. So the median is 8 plus 15 divided by 2, and that's 23 divided by 2, which is 11.5. To the nearest tenth, it's exact. The mode is obvious, the number that repeats the most, and we could see it from here, 19. So the mode is 19. Number 10 is a lengthy one, but to make it happen and reduce the amount of time for the video, I usually prepare my notes, and I'll show you what do I mean in just a second. Let me go over this as a concept first, and I'll show you how I save you some time from writing notes. The following scores were ordered on the midterm exam in Chemistry 102. 93, 81, all the way to 96. Find the lower quartile. In short, we call it QL. Well, here's how we do it. First, let's count the numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 here, 12 here. That's 24, 25, 26, 27, 28, 29, 30. So n is 30. N is 30. That means it's even. We start with the median. So we have 15 numbers right here, 15 numbers right here after you put them in order. And let's say we take the first number right here, the last number right here, take their average, and that will give me the median. The median is the middle number after you list the numbers in order, and also is the second quartile. The first quartile is the lower one, the second one is the median, and the third quartile is called Q3. So Q1, Q2, Q3. Q2 is the median, and Q3 is the upper quartile. Q, U, sometimes they call it. Now, here's another concept. Since we are focused on the lower quartile, we are thinking about this 15 right here. So we have to think this way. 7 right here, 7 right here, that will make it 14. This right here will be the lower quartile. And that's how we do it. So when it's odd, it's easy. You just divide them into 2 parts, leave one in the middle. When it's even, you just look for the middle 2 and take their average. So I do have the numbers in order for you, so I could save you some time. The lowest number was 59, and the highest number was 98, as you could see. Lower number, the lowest, and the highest. And as I said, we have 30 numbers, so up to 15 will be half. And the second 15 from 16 to 30 will be the second half. The middle 2 numbers will be 81, 81 for some reason they came up to be the same. To take their average is going to end up the same. So the median is 81. Now, we need to look right here to the middle number and find the lower quartile. 15 numbers, 7 and 7. As you can see, the 7 is clearly marked with light green. The second 7 starts from 9. So I could leave 1 in the middle, and that will be my lower quartile. So my lower quartile is 71. Let's continue more since we are into the problem. This would be the upper quartile, 89. 71 is the lower quartile, and 81, we just talked about it earlier, which is the median. I think that should do it for number 10. Number 11. To find the standard deviation, our book talks about the standard deviation but does not actually go deep and tell you that there is 2 types. There is a population standard deviation and there is a sample standard deviation. So when the numbers are given and not too many, we call it population because we are considering all the data. When the data is too high, we just take a sample to find the standard deviation. Of course, sampling is another topic, but we call it sample standard deviation. In this case, when it says find the standard deviation of the following data, they're not telling me that it was taken from a bigger set of data. So it's not a sample. It's the regular standard deviation. So that is this right here. Sometimes for the convenience, we just write S. And we, instead of mu for the mean, we write X with a bar on it. So, as I said, we could see that I'm using X minus X bar, just like the book. So the way to do it, here's the numbers. 25, that's this 25, 13 next to it, 32, 40, 61, and 57. We add them up, and I do have the numbers next to me so to save you some time from grabbing a calculator and do it. 228. To find the mean, which is supposed to be called mu, but as I said, like your book is using X bar, so I'll keep it. We divide the total, the sum, 228 by n, and you could see that n is 6. There's 6 numbers, and I have 38. Now, this right here, the second column, is finding the distances away from the mean. Of course, the mean is going to be somehow in the middle. So the numbers on the right will give you a positive distance. The numbers or the from the data on the left of the mean will give you different or negative differences or distance. Excuse me. So this right here will be 25 minus 38, and that is negative 13. When you square that, we get 169. Another example, let's go with 40. 40 minus 38 will be 2. Square that will be 4. Continue that, and I have 1,728. So the standard deviation will be the square root of that sum, 1728. Let's go back and fix this. The square root of the whole thing. So that's square root of the whole fraction divided by 6. And if I go back to the sample and the population, that's mainly the difference. divide by n or divide by n minus 1. Approximate to 16.95. Need more details? This is another slide just to discuss. Here's more details. So this is how you do the population standard deviation from a data given to you, which is not a sample. First, we find the mean. We find the differences away from the mean. Some will be negative, some will be positive. Square that, add them up, and put it inside the square root after you divide by 6, of course. Number 12. At one high school, students can run the 100-yard dash in a mean of 15.2 seconds. So let's keep that in mind. The mean is let's call it x bar or mu. It's supposed to be mu, by the way. I'm gonna go back and change it to mu. So mu is 15.2 seconds. The standard deviation is 0.9 seconds. The times are very closely approximated by a normal curve. So for normal curves, we use the z-scores. We call it standardizing the data. So we change x's to z's and get the benefit out of the normal curve. Rounding to the nearest tenth of a percent, find the percent of times that are less than 17 seconds. So 17 seconds is our x. That is x. This is how we do it. The z-score that corresponds to x equals 17 is something we need to start and find. So z equals x minus mu, the mean, over the standard deviation. And that is equal to 17 minus 15.2 over the standard deviation, which is 0.9. 17 minus 15.2 is exactly 1.8. Divide that by 0.9, which is 2. Now, z is 2. Now you could see that the mean is 15.2 and our number is to the right of it. 17 is higher than 15.2. Well, it's higher by 2 standard deviations. That's the meaning of z equals 2. Because all what you are doing right here is finding how many standard deviations the number is away from the mean. Now, to help you with this problem and save you some time, I do have reading z equals 2, and this is how it's represented as a percent. This is 2.0, no fractions, 0.00. So we are reading 0.9772. So that is z equals 2. And the data in the table, as this shows, it's the area to the left. And the total area is 1. So we consider that as a percent. So when z equals 0, that's halfway in the middle. the area on the left will be half 1, which is 0.5. As a percent, we read it as 50%. Well, this right here, as an area, reading it from the table, we could see that this is 0.9772. To read this as a percent, we call it 97.72%. That should be the answer to the question. Let's see if I have more. Yes. So this right here, as an area, it's see my notes, 0.9772. As a percent, it's 97.72%. And that should do it. Number 13. Well, this right here, it says between. So we have the same concept, except the keyword between. So here we go. The mean is 15.2. The standard deviation is 0.9. And everything is about the same, except we need, from the last two lines, find the percent of times that are between 14.3 and 16.1. Notice that 14.3 is less than the mean, and 16.1 is more than the mean. So we're going to see that as a graph. So that is my x1. That is my x2. Let's fix that. So we need to convert that to z1, convert that to z2, and we'll move on. So z1 equals x minus x bar over sigma. So we have 14.3 minus the mean, which is 15.2 over 0.9. Doing the math, I do have negative 0.9 over 0.9, which is negative 1. Z2 now will be 16.1 minus 15.2, and that is 0.9, divided by 0.9, and that is exactly 1. So what does that mean? It means the following. So here's a quick sketch of the graph. This is when z equals 0. And we came up with z1 and z2. z2 and z1, and that's what they want. So the way to do it, we're going to find under 1, and we're going to find it under negative 1, and subtract them to find the difference between them. Here's z equals negative 1, exact, 0.1587, and here's z equals 1 exact. So this right here is, of course, we always read it to the left as the table says. In case the book is giving you the graph on the right, you have to keep that in mind. But most books, they use the left side. So for negative 1, it reads as 0.1587, and under 1, of course, it's more than 50%. It reads as 0.8413. Next, still number 3, and this is what I have. I have under 1, I said it's 8413, and under negative 1, it's kind of hard to write inside, 0.1587. So in between them, you need to subtract 0.8413 minus 0.1587, and the answer is 0.6826, and that is what's in between. To read it as percent, we read it as 68.26%. To the nearest tenth will be approximate to 68.3%. Number 14. Population is normally distributed. What percentage of the population lies to the left of the population z-score 0.66? Again, as you can see, it's to the left. Well, in this case, there is not much calculations. All what I'm giving is the z-score. So I need to find from the table, this is again when z equals 0, 0.66 will be less than 1. I need from the table to read this right here. That's pretty much it. So here we go. 0.600 is right here. That's 0.600. But we don't need 0.600. We need 0.666. So let's undo that, and we'll go all the way to the right. Now I read this as 0.66. And where they meet down below, that is what we have. That's how we read it. 0.7454 as a percent, 74.54%. So as a percent, 74.54%. If they want it as what percentage of population lies to the left, so they're just saying percentage. They're not saying to the nearest tenth, so we're good. Number 15. A number cube labeled with the numbers 1, 2, 3, 4, 5, and 6 is tossed. What are the odds? This is not probability, it says odds. In favor, sometimes against, of the cube showing 4. So the focus is on 4. Odds in favor. So you need to separate the numbers into two groups. Some with you in favor and some against you. Imagine if I go like odd and even, that will make it even. So in case you want to play a fair game like flipping a coin, but you don't have a coin and you have a number cube, you could say, okay, if I get 1 or 3 or 5 odd numbers, I'll win. And if you get even numbers, 2, 4, 6, you win. So in favor, it's going to be 1, 3, 5 on my side. And against will be 2, 4, 6. That's like 3 to 3, which is like 1 to 1, which is a fair game. In this case, we're just in favoring number 4. So number 4 is on my side. And all these numbers are against me. 1, 2, 3, 5, and 6. Since they're total 6, 1 is on my side, 5 will be against me, and the answer is, for this problem, is written as 1, 2, 5. Of course, it's not a fair game. That's odds in favor. Odds against would be 5 to 1. Okay, that should do it for number 15. Number 16. 2 dice are rolled. Find the probability of the event described. The sum is 5 or 12. Well, if you get 1 on top on each of them, the sum will be 2. and the highest sum will be 12. That's when you get as this picture. This picture shows 6s on top, so the sum should be the highest, which is 12. So we could get a sum of 2. That's from 1 and 1. That's number of ways, which is only one way. A sum of 12, which is 6 and 6, that's only one way. And so on and so on. I could get a sum of 3. Sum of 3, which is 2 and 1 or 1 and 2. That's two different ways. Sum of 11, which is 5 and 6 or 6 and 5. Of course, if the dice are colored like blue and red or blue and green, I could say like I'm gonna get 5 on red and 6 on green, that's 11. Or I could get 6 on blue, 5 on green, and so on. You get the idea. That's two different ways. I could get a sum of 4, 3 different ways. 3, 1, 1, 3, and 2 and 2. You see the pattern, that's why I'm doing it this way. 4, 5, let's keep going and save you some time. 5, 6, 7, 8, 9, 10, 11, 12. So the numbers will be 3 here, or the number of ways. 4 and 4, 5 and 5, 6. The highest possible number of ways to get a sum will be for the sum of 7, and that's 6 different ways. Let's go back to the question. The sum of 5 or 12. Sum of 5 or 12. So let's focus on that. Sum of 5 and sum of 12. We get 4 different ways for 4 different ways to get a sum of 5 and 1 way to get a sum of 12. So the answer for this will be the probability for getting a sum is 5 or 12 equals 4 plus 1 divided by 36, which is 5 over 36. There's 36 different ways we could have it. If you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 or plus 5 plus 4 plus 3 plus 2 plus 1, you get 36 total. So the 36 came from here. Okay. Each topic could be explained as a whole lecture, but I'm trying not to go off. But this is kind of like a quick concept that you get 1 and 1, 2 and 1, 3 and 1, 1 and 2, get 2 and 2, and so on, 6 and 6 at the end. That shows the 36. There's 36 dots right here. Different ways you could have numbers on top. So that should do it. Number 17. Playing cards. When a single card is drawn from an ordinary 52 card deck, find the probability of getting a heart. Well, that's a simple one. We know that these are the hearts right here. Let's see. These are the hearts. And you could see that the 52 cards altogether, that's 52, is divided into 4 equal number of cards. That's 13 in each. 13 here, 13, that's 26, 13 here, and 13 here. So that's the 52. Okay, now to answer the question, the answer is getting the probability of getting a card that is a heart will equal 13 out of 52. If you reduce divide by 13, divide by 13, you get 1 out of 4, which is clearly 1/4 of the times on average, like 25%. Number 18. A card is drawn from a well-shuffled deck of 52 cards. what is the probability of drawing a face card or a 6? Face cards are 12 cards, and the number 6 appears in 4 cards. These are the 4 cards. Or refers to union, and I have the formula on the side, so let's apply it. Knowing that, or agreeing on that, let's call face cards A, and let's call the cards with the number 6 B. So P of A union B will be P of A, which is face cards, that's 12 face cards out of 52, plus for B, the number 6, we have 4 out of 52, minus the intersection. There is no intersection as we agreed on. These guys and these guys, they have nothing in common. So going back, we have minus 0 out of 52, and that will give me 52 is a common denominator. 12 plus 4 is 16. Simplify, divide by 4, divide by 4, and I get 4 over 13. That's the answer. Now, because the union right here for these two sets A and B are disjoint, I made another problem like number 18 by a newer version. Here we go. Now we're looking at the same 52 cards, but we are looking at two sets, face cards or diamond. These are the face cards and these are the diamonds. But notice that they do have an intersection happening right here. So going back, let's call face cards A and call diamonds B. So P of A union B will be P of A for the face cards. We said that it's 12 face cards out of 52 as a probability, plus P of B diamonds, those are 13 cards, the diamonds. So we have 13 out of 52, minus the intersection. The intersection is happening right here between the two sets of cards. That's the first set, and that's the second set. So minus the intersection, which is 3 out of 52. And the answer will be 52. We could subtract 13 minus 3. That's 10. 10 and 12, 22. So we go back and write 22 here total. 12 plus 13 minus 3 is 22. Simplifying, we could simplify this by dividing by 2, and the answer is 11 out of 26. That's the answer. So in case if you do have an intersection, you need to be careful and apply this. The last problem, number 18, also did not have any intersection. Now we're done with the problem, but I want to add to it something as a note. So I could do this in a different way. I could say, or, since I see the picture, we're looking at face cards or diamonds. Those are the face cards. and those are the diamonds. Since I have it, when I count the lower part to the right, I do a double count. That's the idea of subtracting the set in the intersection. Let's count them. So if I count them, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 over 52. Just by counting them. And that is 22 over 52. We're almost there, 19 and 20. If a single fair die is rolled, find the probability of a 5. Given that the number rolled is odd, that's called the given conditional probability. The formula is, for the conditional probability is P of A / we don't read it as / we read it as given B. In this case, well, A is going to be 5. That's going to represent A. And rolled is odd. That's going to be called B. So 5 is, or the set A is just 5. The set B is 1. We're looking at odd numbers, 3 and 5. For the intersection, we need the probability of getting the intersection, which is 5. You could see that the intersection is 5. P of B is odd numbers. Getting the numbers 1 and 3 and 5. The probability of getting 5 is 1 out of 6. And the probability of getting odd numbers is 3 out of 6. Changing this division to multiplication, that shows 1 over 6 divided by 3 out of 6, or differently, as I mentioned, changing it to multiplication, I have to flip this side. Now, this cancels, cross cancel, divide by 6, 1, divide by 6, 1, and the final answer is 1/3. That's the final answer. Okay, last problem. How many ways can a president, vice president, and secretary be chosen from a club with 11 members? So if you notice right here, we have 3 titles. And total, we have 11 members. To do this problem, since we do have titles, order matters. So we call this one permutations. If order does not matter, to pick 3 persons out of 11 members, order does not matter, which is called combinations. I think I do have more slides for it. Let's see. So this is what I mean, just to save you some time. Number of permutations where order matters of n things taken r at a time is called NPR, or P of nr, which is n factorial over n minus r factorial. So in this case, we have n equals 11, and we are looking at the president, secretary, and vice president, so r equals 3. Finishing the problem, we could write P11, take 3 every time with order matters. How many different ways? We could have 11 factorial over 11 minus 3 factorial, and that is 11 factorial over 8 factorial. Instead of using the calculator right away, we could reduce our numbers, then reach out for the calculator. That's 11 times 10 times 9 times 8 times 7 times all the way down to 1. All the way down to 1. And 8 factorial will be 8 times 7 times 6 all the way down to 1. If you notice, I wrote the 8 under 8 so I could show you clearly that this portion cancels. So all what you have left is 11 times 10 times 9 only over 1. I don't need to write that one. And that's 990 different ways. It seems a lot, but that's the power of math. Okay? We could investigate more and show more, but as I say, like, I'm trying the best to go over 20 topics or 20 ideas in less time. It's a little bit hard to make it in less than an hour, but having everything colored, ready to go, that's my style to save you some time. Because if each problem I could just take like 5 to 10 minutes at least to go over, minimum. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.